Hello, CP Algebra 2B, and welcome to another lesson here. This is a continuation of solving radical equations, just a little more challenging ones today. So this is day 2 again. Just remember, to solve radicals, one of the first important things to do is get the radical by itself. So we want to get the red radical all by itself. To do that, we're going to subtract 8 from each side. Okay, so what we end up with is the radical of x minus 6 is equal to x minus 8. Pretty cool stuff. Now, to get rid of a radical sign, you can square the one side. Now, in mathematics, whatever you do to one side, you have to do to the other side. So it's going to be nice on the left because that would just be x minus 6. On the right, we are going to have x minus 8 squared. Oh boy, this is where all of your fun factoring comes back into play. Remember that x minus 8 quantity squared. It is not just x squared minus 8 squared. Okay, no. It's the whole quantity times itself, which is going to make you need to FOIL. Okay, remember our distribution pattern. X times x is x squared. X times negative 8 is minus 8x, another minus 8x, and then a plus 64 means that we have x squared minus 16x plus 64. That's going to be set equal to x minus 6. We're going to swing that plus 6 over, and we'll also subtract x over, which would give us x squared minus 17x plus 70 is equal to 0. And at this point, you have a lot of different ways that you could solve this. You could use the good old quadratic formula, a or b squared, negative b squared plus or minus square root and all that. Or you can just try and factor again. So most of these ones are going to factor. Again, factors of 70 that add to negative 17. That would be x minus 10 and x minus 7 equal to 0. At this point, you can split the problem into 2, set the other side equal to 0, and you get x equals 10 and x equals 7 if you solve for x on each side. Okay, so those are two possible answers. Now, with these ones, we said last time you need to check for extraneous solutions. Okay. So check for non-solutions, or extraneous we call them. You want to try both of them. So we are going to substitute back into the original equation. All right, so the square root of x minus, we'll do 10 first. Okay, actually 10 minus 6, I'm so sorry. 10 minus 6, okay, plus 8, is that going to be equal to 10? So I'm checking out this 10 here. Well, 10 minus 6 is the square root of 4 plus 8. That's 2 plus 8, which is equal to 10. So that one works out. Now, if we try the other one, so let's kind of see what happens. The square root of 7 minus 6 plus 8, is that equal to 7? So we're trying out the 7 this time. 7 minus 6 is the square root of 1 plus 8 is equal to 7. Well, the square root of 1 is just 1 plus 8 is equal to 7. That is false because 9 is not equal to 7. Okay, so the only real solution is x equals 10. That one is good. X equals 7 is not actually a solution. It's a trick. So x equals 10 is your final answer. Okay. You should specify whether or not they're extraneous or not. So another example, example 2. Same idea, get the radical by itself. Hey, it already is. So we're just going to start off squaring each side. That would just be 7x plus 15 is equal to, remember this is x plus 1 times the quantity x plus 1. If you FOIL that, you end up with x squared plus 2x plus 1. Solve it for 0. So subtract the 7x, subtract the 15, gives you x squared minus 5x minus 14 is equal to 0. We'll try and factor again. Fortunately, x minus 7 and x plus 2 will get us to where we need to go. And we have then solutions of x equals 7, or possible x equals negative 2. Check. So again, check both of these. So we're going to check 7, and we're going to check 2. Okay, for 7, that just means 7 plus 1 is that equal to, is that equal to square root of 7 times 7 plus 15. 7 plus 1 is 8. Is that equal to the square root of 64? Yes, indeed, they are. So 7 checks out. Negative 2, so let's try negative 2 plus 1. Is that equal to 7 square root, times negative 2 plus 15. In this case here, we have negative 1. Is that equal to the square root of positive 1? And negative 1 is different than 1, so that is not a solution. You don't need to square that one off. Okay, so be aware, be careful with those, and that's really the main idea. It can get trickier yet, so let's just kind of see what all goes on with this one. This is a particularly challenging problem. So here, even if we add so you don't need to write this, even if you subtract the 1 over, it's not going to isolate any of the radicals. You can't really subtract them. So we are just going to start right off the bat squaring each side. Now it is important that you square everything, including that 1. Alright, so we're just going to start again, just kind of writing this out as the square root of x plus 2 plus 1 times the square root of x plus 2 plus 1 is equal to essentially what's in here would just come out. So 3 minus x. So really just kind of follow along for this first one. The square roots, don't cancel them because we have this plus 1 funky thing at the end. So we'll rewrite it like that. What you can think of this as is, FOIL. It's going to look challenging, but you could do it. Square root of x squared plus 2 would just be the square root of x plus 2 squared. Okay? The square root of x plus 1 would be plus square root of x plus 2 plus the square root of x plus 2. You do outers and inners. And then the last ones would be plus 1. It's going to be equal to 3 minus x. So what we have going on here is, well, in this case, it's kind of nice because this is just going to, poof, disappear. That's just going to become a regular x plus 2. Okay, the squared and the square roots will cancel. Plus, we essentially have 2 of these. You can add radicals that are the same. So you have 2 square roots of x plus 2, and then we have a plus 1 equal to 3 minus x. Alright, from there we can start to kind of shake and bake some more. So let's combine the like terms, the plus 1 and the x minus 2, and we'll just write the radical out front. We would have 2 radical x plus 2. 1 plus 2 is 3, and x, so plus x plus 3 is equal to 3 minus x. Now let's work to get the radical by itself. So let's subtract x, subtract 3. Okay, that will give us negative 2x is equal to 2 square roots x plus 2. Whew. Divide each side by 2. So negative x is equal to the square root of x plus 2. Now we'll square both sides. Okay, What that ends up with is just x plus 2 is equal to x squared. And we will set equal to 0 and then solve. So I'm running out of space. So set equal to 0, so minus x minus 2 means we have x squared minus x minus 2 equal to 0. We will factor. Once you have a trinomial, try and factor it. So x minus 2, x plus 1 means that x is equal to 2, x is equal to negative 1. And again, we are going to need to check. Okay, it could be a doozy to check all these, but we'll just kind of hopefully see it's not too bad. So we're going to check 2, and we're going to check negative 1. 2, substituting in 2 is just square root of 2 plus 2. Is that plus 1? Is that equal to square root of 3 minus 2? 3 minus 2 is the square root of 1, which is just 1. And is that going to be equal to square root of 4 plus 1? Well, that's 2 plus 1. You can easily see that one is not a solution. Okay. For negative 1, on the other hand, let's just see the square root of negative 1 plus 2 plus 1. Is that equal to square root of 3 minus negative 1, essentially? That's the square root of of 4, which is 2. Negative 1 plus 2 is 1, and then the square root plus 1. And you get 1 plus 1, which is equal to 2. So that one works out. Okay, whew, that one is a challenging one. But just take your time. It's a lot of algebra, a lot of foiling. All right. So I have a challenge for you. Try this one out. Pause it right now. Try it out. Come back to it. See if you get it right. I will lead the charge. So the first thing, square both sides. Which is square root of x plus 6 minus 2. It would just disappear. Minus 2 roots x plus 6. Plus 4. Subtract this 4 over. X plus 6, that's what that just becomes. Minus 4 roots x minus 6. Ooh, nice. X's will cancel. No, that's a plus. Sorry. Hey, it works out. X equals 3 is your answer for that. All right, so nice job if you got that. All right, if not, try and go back, see where you made a mistake. And of course, try some of the problems that follow. And that is, I believe, one of the last lessons of this particular chapter. So good luck, and thanks for